All right, good afternoon, everyone. We'll be getting started in just a few minutes here. We're waiting for a few more registrants to join. You should be able to see our first slide there, and you'll get camera of each of us speaking as well shortly. So if you're having any difficulty, please enter some information in the chat box. We'll try to help you as best we can. We'll get started here in just a few minutes. I'm just going to give one more minute for everyone to get logged on that's registered, and we'll begin. Thank you for joining us today. Okay, we have 2 minutes past the hour, so we want to be respectful of everyone's time and also give ample time for question and answer at the end of this discussion. My name is Jim Rogers. I am the Chief Strategic Officer at Dawood Engineering, and we appreciate you joining us today for the first in our series of summer webinars here. Today we'll be discussing survey technologies and the effectiveness of forward thinking. And we have a panel of our colleagues here at Dawood that will be sharing their current expertise and experience using new technologies in survey. For those of you that don't know much about Dawood Engineering, we've been in business for 28 years, and for almost all of that time, we've been conducting survey projects in support of the civil design projects that we've served, working on some of the largest transportation and energy projects in the Mid-Atlantic and in states beyond. About a year and a half ago, we acquired surveying and mapping consultants in Braintree, Massachusetts, which further expanded our survey capabilities and added a repertoire of additional technologies that we'll be discussing today. So joining me on the panel this afternoon, we have three of my colleagues. I'm joined by Kevin Hanley. He is the regional manager for our Braintree, Massachusetts office and the founder of Surveying and Mapping Consultants. And he'll be sharing some of his experience in several decades of service to the civil construction and design industry, providing survey and mapping services. Also, we'll have Noel Poynton, our senior survey manager, working with the New England office in Braintree, who is based in Dublin, Ireland. He'll be talking specifically about some of the tools we're using. And we also have Jody Carter, our senior survey manager and licensed surveyor in our Harrisburg headquarters office in Pennsylvania. So I appreciate you all joining us today. This is the first time we've conducted one of these webinars, so bear with us on the technological aspects of it. We're going to encourage you to ask questions. We'll go through our presentation first, but if you have questions at any point during the discussion, we encourage you to put them in the Q&A tab within the webinar, and we'll work through those as we get through our formal presentation, and want to encourage you to continue to ask us more. We will also be recording this session, so if you want to share it with your colleagues, please let us know. We can give you a link to the recording. And also, if there are elements of this presentation that you'd like more detail on, feel free to reach out to us directly through the invitation email you received, or at info@dawood.cc, or to any of us that are on the panel today. We'll share our contact information at the end. So with that, I'd like to begin, and I'll start with Kevin Hanley. And Kevin, I appreciate you joining to share your experience here. I'd like you to kick us off by talking about why technology improvements are important in surveying and mapping, and the things that you've seen in your career that have been advances in improvements to how we collect data surveying in the field.
Thanks, Jim, and welcome to all our attendees. Certainly over the years, Jim, I've seen lots and lots of technology from microwave by tellurimeter back in the 60s, early 70s, visible light by geodometer, which is of great interest as I progressed through the technology changes I've seen over the years. We then went to infrared with Hewlett-Packard, who's no longer in the surveying business. We then went to lasers. The first total stations were by Hewlett-Packard and Zeiss. GPS, currently important all over the world by all kinds of people, not only in the surveying and mapping professions, but for general day-to-day use. Developed at MIT and the first instrument was called a micrometer. Then we've progressed to laser scanners, mobile LiDAR, drones. Digital mapping has been around since the early 80s. And we've been involved in the technology, airborne LiDAR in 2009, mobile LiDAR since 2011. Why is it important? It's important because, as Bonnie Dawood, the founder of Dawood Engineering, aptly stated a few days ago, that we want to give clients what they don't know they want. And simply, if you look at the educational system for engineers and surveyors throughout the world, more and more of the graduates are coming out with training and in-depth experience in 3D design. So the only way to provide that level of detail is to use the technologies that we have. And certainly over all the years that we've been around, one thing that's never changed, that is the experience that's guided by seasoned judgment. And more importantly, it is how to use the technology. It's not just pushing buttons, although that's how they work, but it's very important is to apply the technology to all kinds of things that can be measured. And it's important to think outside the box.
Kevin, that's a very good segue to discussing how these tools allow us to think outside the box. I'd like you to talk a little bit about the technological advances as it relates to safety in field data collection.
Well, certainly the technology way back when required people and surveyors to be on highways, on railroads, and even with normal safety precautions, typically surveyors are in harm's way. And the use of modern technology, particularly laser scanners and mobile LiDAR, takes staff, for the most part, out of harm's way. That we can accomplish tasks more safely and much more efficiently than we could in the past. But when you look at the ranges of laser scanners and mobile LiDAR systems, we're looking at the low end, maybe 20 to 30 meters, but at the upper end, using our Trimble SX10, we're in the order of 800 meters away. So depending on the application, you can be quite a distance from the object that you're measuring.
There's some advantages there too, Kevin, in terms of the efficiency and timing of projects, right? So not only can you be off, say, a railroad right of way, but you may not need assistance with access and so on.
Yes, we've had a number of examples over the years of using our technology, initially at Trimble VX Spatial Station, and currently the Trimble MX2 and our SX10. But kinds of projects where access to railroads is it takes time. It may take several months. We've been involved in a project regionally that it almost took a year and a half to get permits to access the railroad. But with new technologies and the application of those technologies, you can be off the property and still make extremely accurate measurements of the details on, for example, a railroad.
When you're collecting data like that too, Kevin, does it allow you to go back and answer questions that come up at a later time?
Oh, absolutely, Jim. And one of our first forays into mobile LiDAR was for the Fast 14 project north of Boston, interstate highway, 4 lanes each way. And while we had limited details to survey in the beginning, once the design build team came on board, they had a need for more data. And specifically, they wanted a terrain model of the high-speed lane and elevations along the median barrier. And because we had used mobile LiDAR, we were able to deliver 3+ miles of interstate highway and deliver that DTM within 25 hours. We missed the delivery by 1 hour, but it's those kinds of things. Other projects that examples and interesting, we had a client ask us after we had delivered our essentially 2D base drawings, that could we determine the heights of hydrants? And using the tools within the mobile LiDAR software, we were able to generate the heights of each of the hydrants in the project. Another example was at an intersection survey here in eastern Massachusetts. Several months into the design, our client came back and asked if we could determine the height of a signal, a traffic signal that was strung diagonally across the highway. And within minutes, we had the answer for the clearance. Another example was on an interstate highway, which again takes time to get permits. We might need to have lane closures if we were doing it conventionally. But we had mobile LiDAR data. Our scope was to do an as-built of the recent paving and blend that with the existing aerial mapping. The client came back several months later and asked about the clearances of an electric transmission line across the highway, and also the location of piers in the median. And within an hour or so, we had provided the answers, the clearance of the transmission line, as well as the location and elevations of the piers.
Excellent. Now I'm going to ask our team to pull up an example here of a recent project we worked on where we've applied technology in a way that's different than perhaps you'd have done this 15 or 20 years ago. And that's the survey that we did of Cambridge's town hall in Massachusetts. So Kevin, could you talk about how we might have tackled a project like that earlier in your career versus using the technology today?
Well, just a few short years ago when I started my career, we would have used very simple methods. Typically with a 6-foot rule, we would have measured specific details of, for example, windows at the ground level that we could access easily, and then relate that to the various other windows on the facade of the building. Another method would be to use classical triangulation to define a specific point on the facade and locate that by angular measurements from 2 locations. And then more recently, using the direct reflect features of our normal field instrumentation, we would have been able to measure the angles and the distances to those points. But as you can see in the image that's on the screen, using our SX10, within several minutes, we have very finite detail, not only of the facade of the city hall, but also of the buildings across the street.
That's a great segue. I'm going to ask Noel Point to elaborate on some of the tools that we used on this project and similar ones. Noel, could you share some of the attributes as, based on the scope of work we were initially engaged to perform on this project and what we were able to provide after the fact?
Yeah, absolutely. Thank you, Jim. Hi all. Sorry you can't see me. Some technical issues here with my webcam in Ireland, but I gather you can hear me. But more importantly, I hope you all can understand me as I go through this. Just a little bit more of a background on the Cambridge project that Kevin just referenced. A leading architectural firm in Boston contracted Dawood SMC just to simply produce a simple topographical base plan along with a definitive right-of-way of this historical and iconic building. In developing our approach, we decided to utilize our S6 Trimble total station and our, at the time, newer Trimble SX10 total station scanner. Using the SX10 scanner with its capability to scan up to 26,000 points a second, we were able to, as Kevin mentioned in his brief discussion, we were able to quickly and accurately scan the whole building, the facade of the whole building, in a few short hours, which was phenomenal. Now, as we had mentioned earlier, the client here was only looking for a basic 2D plan, but having used the SX10 scanner, we now had a registered point cloud that could be used at a later stage. So we took the data back to the office and we processed the data, and from it we extracted the information that was required to produce the 2D simple base plan, but also on file now we had a registered point cloud. So we delivered the plan to the client, and during a subsequent follow-up phone call just to see if the client was happy with the deliverable, I mentioned to him that we had taken the opportunity to scan the whole building using the SX10, and that we had a registered point cloud that if he needed, we could send. This certainly surprised him happily, and he asked that we send it over, so we did. And I can let you know that since then, apparently, they have used our point cloud to produce a 3D CAD model that they're going to use for historical preservation purposes. In this instance, the client had the ability to perform the 3D CAD modeling themselves. But I just want to let people know that if there is a need with any of their projects, we do have that capability in-house to produce 3D CAD models if you don't, or if you need assistance, if the project's large, you need assistance, we do have the capability to help out. Back to you, Jim.
So that's a great example of us helping to solve a problem, as Kevin put it earlier, that a client didn't know that they had at the beginning. But sometimes we come to a project with a scope of work that's difficult to manage all on its own. Could you talk about some examples of ways we've used technology to tackle difficult and challenging projects?
Absolutely. We were actually had a survey request to produce once again what appeared to be a simple base plan of an underwater tunnel that connected two surface manholes on either side of the 4-point channel in Boston. The tunnel itself was approximately, there's on the screen, the tunnel itself was approximately 640 feet long, and the two shafts on either side were about 75 feet deep. So it was actually quite a challenging project straight off the bat. The client had requested that we survey the utilities, the landings, the pipe network, the ventilation equipment, the duct banks, and the supporting brackets that held the actual pipe itself along the length of the tunnel. So we knew we had our hands full with this one. So in developing our approach, we actually decided to go with our 3D high definition fire focus scanner, mainly because it gave us the ability to scan with it in an inverted mode. And we felt that that was the best option in order to capture the scan data required, especially in the two shafts, which were going to be difficult, and along the length of the tunnel itself. Because of the limited time available to us to carry out the scanning and taking into account the difficulty that was going to be encountered by our crews, such as dampness, high humidity, having to carry oxygen tanks, wear oxygen masks, and the fact that we found out afterwards that at high tide, the tunnel itself flooded to about 1 foot above the floor of the tunnel. So obviously, traditional traversing control techniques in order to control the targets during the scanning wasn't going to work. So we had to come up with an alternative, because at the end of the day, we have to get it done. So we decided to go with a target-to-target registration process / technique here. So basically what we did was we placed targets at strategic locations in the 2 shafts and along the length of the tunnel along the tunnel itself. And we moved the Faro scanner between the targets, and ultimately trying to capture as many of them as we could within each scan. The reason being, when we went back to the office to process the data, what we ended up having to do was to basically create a mosaic of all the scans. So you're basically placing the scan you're working on right now with the previous one done. So you're kind of just building, as I say, a mosaic of the scans. In the end, it actually worked out quite well. The client had originally requested a horizontal accuracy of ±6 inches. When we actually finished our registration and tied into some control that we set ourselves up on the surface, we found that we hit the control actually to within a tenth. So it actually worked out pretty good. At the end of the day, the client got his base plan. He also came back at a later stage and asked us to produce profiles at 50-foot intervals along the tunnel itself, which was easy enough to do because we had obviously captured the data in 3D, and using the software Trimble Reworks, we were able to expedite that request quite quickly and provide it to the client in a timely manner. So just another use, Jim, of some of the equipment that we have in our arsenal. And as I say, in this instance, we use the Faro Focus 3D high definition scanner. As I say, just mainly because it gave us that ability. If you go back to the previous slide, it gives you the ability to invert it, and trying to get up and down the shafts we knew was going to be very, very tricky. You couldn't just scan with the Faro in its upright position. We had to come up with a way to link the scans. So you would scan with the Faro in an upright position, and then you'd invert it so that you would get an overlap in the scanning. So it was a challenging task, but we did it. And at the end of the day, we believe we delivered a fit for purpose plan to the client. They were happy, and so were we.
I appreciate you sharing that, Noel. I mean, these are challenging environments to work in, and you can just see illustrated from that model the difficulty and the safety constraints of working in a confined space like that in order to make that work. So it's a great example of the problem-solving technique we've used with these newer technologies. I wanted to talk a little bit about, Noel, the ease of access of the data. You mentioned that in some of the samples that we're able to provide and models, but we've mentioned earlier that there are questions that may come up after the initial scope is completed. How are we able to share this data with our clients?
Yep. So apart from the normal base plan deliverable that can be provided, obviously, when we do a scan project, we will also provide the client with an executable file that can be opened inside a browser. And with this file, you're able to basically navigate through the scans and take rudimentary measurements. So let me just share my screen so show you what I'm talking about. And can everybody see that, hopefully? Sorry, folks. Looks like the internet got a bit slow there.
There we are, Noel.
Excellent. Sorry that the internet just slowed down a little bit. But when you click on the file that we provide, Jim, as I say, it's opened in a browser. This is what you see, basically. And all you do is you just click on Explore Project, and it opens up. So what you see here is not a picture. This is a colorized point cloud. So I can move around within the scan data, as you can see here. Each one of those little triangles are scan stations, and I can show you in a second. You can click on any one of them and it'll just jump to a station. But it's incredible what you can see with the Faro scanner. This is actually a bridge that we just recently done in Rhode Island. And I just thought it was a good example to show you what these tool can actually do. So for example, I'm just going to zoom in here a little bit. And over on the left-hand side, hopefully you can see it, there's a measure kind of toolbox. You've got three options basically. Well, you've got four, but three of them are you usually use. If, for example, you needed to get the elevation of the top of the slope, you can simply come over here, click on this point icon, come over to your scan data, click on it, and lo and behold, it will provide you with the northing, easting, and elevation of that point. As simple as that. If you wanted to zoom in a bit closer, and for example, let's say this time around, I want to get a horizontal distance between, say, up here, this bracket, I can click here, and there you go. You got 2.73 feet. If I want to do a vertical measurement, so say, for example, I want to do actually here, the underside of the beam to the concrete, 2.57. So you can make some rudimentary measurements within the this tool itself. But I just wanted to show you something else to say. You can just click on any one of these triangles and it will jump to it. But just want to hark back to one of the things I think Kevin mentioned about the safety aspect of by doing this type of scanning, whether with the SX10 or with the Faro in this instance, it does have some safety benefits. And also, as Kevin alluded to as well, the fact that you don't have to go back to site if you've missed some items. There's a very, very good chance that whatever you need to get is in the actual scan data. So let me just go over here. I just want to click on this one. As you can notice here, there's no lane closures. So there's no need for the expense and the aggravation of trying to arrange for crash trucks, state troopers, and all that lovely stuff. So you've got that added expense that's saved. But just as important, if not more important, the fact that the survey crew doesn't have to go out. Now, in this instance, we got lucky. There wasn't too much traffic. But on a busy day, I'm sure it's something you wouldn't want to be going out into the middle to try and locate or get a shot in the center line or to get a shot underneath the beam. So as you can see, by using this technology, it has the two major benefits of safety, you're not sending the surveyors out, and cost savings as well, that you're not putting back onto the client and they're not putting on back onto their client, where you're having to add in the expense, as I say, of crash trucks and state troopers and having the problem of trying to get them both to show up in the same time and date. So it can be quite interesting. But that's a file, Jim, that we typically always actually deliver as part of our deliverables when we actually do a scan data. So for example, with this project in Providence, the client here will receive this file. Now, some of my fellow surveyors would have noticed when I clicked on the point, it wasn't georeferenced yet. We haven't actually completed the control network, but as soon as we have, I'll go back in and reprocess this, and the information when they click on it will actually be georeferenced and coordinate correct to the state plane, in this case Rhode Island, and also it'll be on the datum. So just one of the tools.
I appreciate you sharing that and the amount of data that's easily actionable and referable for the design team as we're working on them. So I'd like to now turn things over to Jody Carter. Jody, if you could share how we've applied some of these tools on the projects that we've worked on in Pennsylvania as well.
Sure. Thanks, Jim, and good afternoon, everyone. I can think of two projects that recently where we've adopted the technology as you know, they were brought in as alternate methods, part of the problem solving portion of the survey work, and one being this Green Stormwater Infrastructure Project in Lancaster County. We've been tasked with surveying approximately about 3.2 miles of non-contiguous corridors throughout the city, different neighborhoods, different areas. So there was a challenge there. And the biggest challenge with this we had, due to the time constraints and the deliverable time frame, we were really struggling to figure out a method to get the amount of information needed and get it back to the client in a timely manner. So through some discussions, it ended up being that we use mobile LiDAR to tackle this task. And again, given 3.2 miles, we were able to mobilize get crews out there in a period of about 3 hours, complete this survey from start to finish. Of course, we supplemented that with GPS and our S7 robotics to pick up some of the finite details that we weren't able to capture due to obstacles and different things that may have been in the roadway while we were conducting the mobile LiDAR drive-through. But the benefits of this were tremendous, in my opinion. We were able to keep the crews out of harm's way. Again, this was downtown Lancaster, normal work days. We didn't have to restrict traffic. We didn't have to burden people with moving cars and trying to do all those type of coordination factors that causes inconvenience at the same time and keep the cost down. And at the end of the day, we were able to deliver this in basically under 30 days, a full deliverable. And again, having all the data there readily available, that as the project progresses, we're able to provide additional data without having to resend crews out to pick up additional information. So, for mobile LiDAR in this corridor, for me, it was a newer approach because of the density of the population. And I think it went very well, and the client was very pleased with the result.
It's a great example, Jody, and I know we have an example of the modeling that can be done with this sort of data capture that we'll share a little bit later. Talk about some other ways we've used this type of tool or other technologies to work on projects here recently in Pennsylvania.
Sure. The second project I can think of that comes to mind is Harrisburg International Airport. It was a terminal apron survey for a 12-gate redesign, is what you can see on the screen. You can actually see the jetways protruding out there. So each one of those were a terminal. And the scope for this project, we were surveying the lead-in lines, taxiways, service roads. We needed to pick up the stop lines, rotunda footings, the exterior facade. And with this one, there were several challenges, of course. Just looking at it, you can tell. This is Harrisburg International Airport. It's a live terminal. You have live air traffic. You have personnel moving constantly, 24 hours a day. Numerous restrictions for length of periods of time that we could be in certain areas because they can't just stop flight for us to get in the survey. So you can imagine that the challenge of this to just meet it logistically was pretty steep. So again, through discussion, an alternate method was introduced, and we decided that the SX10 was going to be the best tool for this job. And at the end of the day, again, we couldn't be more pleased with what we were able to produce and the agility that having the SX10 provided us, because again, logistically, we weren't able to just start at one end of the terminal and work our way in a methodical manner around the terminal. We were at the discretion of traffic control there. So we might pick up a terminal on the west side and then a terminal on the east side and then bounce to the north and the south. And so having that instrument, a few things, we were able to, again, keep our crews out of harm's way because it is a high traffic area. It's a very dangerous area to be working in, but we were able to put them in safe spots. And very quickly, as a gate opened up, we were able to send a crew in with the SX10, scan that terminal, and be out of the way by the time the next aircraft came in. So ultimately, this was a great use of the SX10. Again, we were able to provide everything and then some to the client, and again have a large repository of information that as this project progresses, and we've had different instances where they have called back and said that, we're looking at this and this, and we feel we're able to capture these lines, and within an hour's time we can provide that additional data without resending crews and trying to coordinate closures just to pick up the odds and end things that may have been needed during the preliminary thought process.
Thanks, Jody. I appreciate you sharing that. And what we're going to do is go back through the panel here and offer some additional feedback and answer one more question. But I want to prompt the attendees here. If you've got questions on the models and technologies we've showcased so far, by all means, take this opportunity to put them into the Q&A box, and we'll work through them there as we get through our last question here. So Jody, I'd like to start with you and just ask you, we're using some of these tools in our present moment. Where do you see this technology in the future progressing?
Yes, Jim. I think I've stated before, I believe that the drone mobile LiDAR scanning technology is on a tremendous upward swing right now, and at some point in the near future, I believe it's going to be integral to the design process, and it'll be a necessity. It won't be, and in my opinion, it's not going to be an optional thing where it's an enhanced thing. I think that once design firms and engineers get their hands on these deliverables and are able to use it in a real world scenario, they're not going to want their traditional TD or 2D deliverable. They're going to want the 3D model that they can have that highest level of a visual representation, that they can basically virtually go through and work on the design of a bridge or a substation or an architectural redesign of a building. I can see it being used, and it's being used now in the city planning process, the architectural process. And ultimately, I believe it's going to reduce the amount of errors throughout the process, and ultimately save people money.
Thanks, Jody. I appreciate that feedback, and I'd like to kick it back to Noel here. Noel, if you could share some details about what you think is next. I think it's a good segue to talk about and share even some of the models that we're able to produce with the tools that we're using currently.
Okay, yep. Thanks, Jim. Yeah, just to add to Jody's statement, which obviously I totally agree, I see more and more clients moving away from requesting the typical 2D traditional deliverable and start moving into the 3D realm and requesting 3D deliverables such as registered point clouds, the 3D CAD models, and 3D CAD models in Revit. All of these lend themselves, Jim, to the next step, which is absolutely augmented reality. In some instances, it's already here. But in the near future, more and more of us, you'll be able to just put on a pair of AI glasses and see the survey that you just was performed and your design in virtual reality. So very, very exciting times. And just want to add to that, I'll share my screen here again. I just want to show everybody a fly-through, just talking about the augmented reality part here. This is a fly-through through a streetscape in just out of Boston, actually. We can get this to work. Hopefully it comes up. And can you see that, Jim?
Yes.
Okay. So as I say, this is a fly-through through a streetscape in a town just south of Boston. I'll just hit play here. So this was captured using our LiDAR, our MX2 system, and it's incredible the amount of detail that can be captured. And this was actually captured, I believe, the whole 3.4 miles in approximately 2 to 3 hours, where we drove down one side and we drove back up the other side. But in the future, you will be able to basically put yourself inside this and pan around and see things in virtual reality. So you'll be able to bring in your design, see how it's going to affect the environment, see what sort of effects it'll have on the butters, so you can get honest and real feedback on actually what your design is going to do and the effect it'll have on the environment. Just a nice little touch here where it goes underneath the viaduct. Some of my friends and colleagues in Massachusetts will probably recognize the viaduct, but I'm just going through it right now. But yeah, so this type of technology that SMC Dawood has at its disposal is a type of technology and deliverables that our clients currently want and will certainly increasingly want as we move forward and we move closer and closer to the reality of virtual reality, and that more and more clients will start actually using it. So it's just quite impressive, Jim.
Thanks, Noel. I appreciate that. I'd like to give the last word to Kevin, and just as a segue there, Kevin, if you could talk about the importance of this type of visualization and the projects that we're working on as it relates to public involvement, showcasing to constituents and regulatory bodies about what the designs and projects are going to look like, and then what you see as the future.
Thanks again, Jim. Certainly, those of us who've attended public hearings and presentations at city councils and town bodies have seen the use of conventional drawings. And a conventional drawing is basically a multitudes of lines and line work to represent features that require interpretation. And it's difficult for the general populace and the attendees at public hearings to interpret what these lines mean. Certainly with the use of our instrumentation that's in use throughout the world, we'll see a greater emphasis on the use of visualization tools, so drive-throughs or fly-throughs, so that the residents of towns and the attendees at communities can see the impact of the proposed features on the existing features. And the future will be a concentration on the integration of data sets from laser scanners, from mobile LiDAR, from drones, including point cloud imagery, so that in working in a remote environment as we are these days, and may more and more in the future, that the ability to present existing conditions with the proposed conditions will have significant impact on these proceedings.
All right, thanks, Kevin. That's a great way to wrap up our formal discussion here, and I appreciate my panelists and their sharing of their experience here and the projects that we've been recently working on. The first question we have is for you, Kevin, from the panel of participants here, and it says, "Hi, Kevin. Is it cost effective to use this technology on small projects such as local streets or bike paths?"
Absolutely, Jim. We have just completed a mobile LiDAR project for a 1,200-foot long street survey for a utility project here in Massachusetts. We've also in the past have used our mobile LiDAR system for a rail trail project north of Boston, and we integrated the mobile LiDAR data with the existing aerial mapping off the right-of-way, as well as supplemental field surveys in wooded areas. It is cost-effective. It's certainly for us, given that we have an in-house system, that we can respond and react quickly to projects. But another example was a public housing project that we did some years ago in the winter of the never-ending snow here in Boston. With the forecast for 3 feet of snow, we mobilized our team to a municipal housing project about 25 miles away, only about 1,200 feet of roadway, but we managed to capture all the data in a matter of hours. And when we had 3 feet of snow that ended up being 9 feet of snow throughout the winter, we were able to develop the base plans for the project. It is cost effective. It's always is a good thing to have a conversation up front as to what you plan on using the data for. As Jody and Noel have related in the last few minutes, that sometimes projects grow in size because of the fact that we have this data. But it's important to have a discussion up front and determine what the data will be used for. Because many times there are questions throughout the design process, and having the 3D data in-house eliminates the need